keep a recording. The first graph, we look at the graph of f of x is equal to sine x. When you want to understand sine graphs, you first consider the properties of the general one, of the general sine function. It must be f of x is equal to a sine bx plus c plus d. While sine and cosine, these functions, even the general cosine will behave, has same properties as the general sine. So we have got key points here. The first one is a period. How do we get the period of the sine function? The period is defined as the interval in which the sine function completes its oscillation. I think that's coming from physics there. So the period has a formula 2 pi over b, which is the same thing as saying 360 over b. So this is in radian, this is in rads, and this is in degrees. First thing, where you are able to see b is the coefficient of the angle, where there is x inside there. 2, we have what we call the amplitude. The amplitude is the measure of the stretch of x. How far does it go from its central line? How far does it go up and below from its line of symmetry? So this is just the amplitude that is given as the absolute value of A. It's always positive because it's the height. You're looking at the height of this. And then 3, we have what you call the horizontal shift. The horizontal shift. Well, the original graph of sine is this one. So when you do this, it's like you're moving it from its initial position to some other positions. So the horizontal shift is the shift along the x-axis. That is obtained by equating bx plus c to 0. And then the fourth property is the vertical shift. This is just d. Just as it is. If it is positive there, you get as a positive. If it's minus, you get as minus. And then we have the most important one is the scale. Or the scale for sine function is given by period over 4. So let me now demonstrate why we are talking of 4 here. On the graph of f of x, maybe we start with, maybe we talk about it as an example. Okay, so we'll talk about it as an example. Examples. Sketch the following. One, f of x is equal to sine x. 0 less or equal to x less or equal to 360. Oh, if we don't know anything about the properties of sine, okay, this is for Jonah. Okay. So if you don't know anything about the period, the phase shift, the vertical shift, the horizontal, but at least you know that if you are given angles from 0 to 360, if we are to go by the old way of using a table, well, we can put a table of x values and then f of x. It would be nice to use what we know. Well, we know what sine 0 is, so we use 0. From 0, we don't know what sine 1 is. We don't know what sine 5 is. We don't know what sine 10 is. We don't know what sine 15 is. We don't know what sine 20 is, but we know what sine 30 is. Okay. And then we also know what sine, but maybe this will be too much because we're looking at 360. From 0 to 360, how many numbers? Maybe we'll have so many numbers if we go this way. So well, even if we know sine 30, just because of where we're going, maybe let's just use from 0, we got 90, and then we got 180, and then we go to 270. So we're using the spaces of 90, and then we go to 360 itself. So we could have used 30, 45, 60, but just to avoid having a long table here, we can just use these few numbers. Then let's check. What is f of 0? Sine 0. Sine 0, we said it's the same thing as 0. So we put 0 here. What is f of 90? This is sine 90. Sine 90 is 1. So we put 1 here. What is f of 180? That is sine 180. Sine 180 is 0. So we put 0. What is f of 270? Sine 270 is -1. 360, sine 360, this is 0. So talking of the sketch, so we have 0, and then we're doing spaces of 90, 180, 270, 360. So sine 0 is 0, sine 90 is 1, and then 180 is 0, and then 270 is -1, and then it is 0. So we have something like this. when we connect. So if we ignore the starting point 0 and count how many important points are there, those that have got names. The first one is the turning point. The second one is the intercept at 180. The third one is the turning point at 270. The fourth one is the intercept at 360. This is the reason why we are using 4 here when it comes to the scale. We say period over 4. So period, we said it's the interval, it's the length of the interval at which sine completes its oscillation. So when it comes down, it's not yet done. To go and get back. So this is the whole period of this one, is 360. So in this case, if we get back to our properties, we'll have the first one, the period, we said is 2 pi, which is 360 over b. So if we arrange this in those properties, you notice that b is 1, the coefficient of x is 1 here. So we get 360. 2 we're recording, don't worry. So 2, we have the amplitude. The amplitude is the absolute value of a, and a here is 1, the coefficient of sine. So we get 1. And as we can see from 0, which looks like a symmetry, we have 1, the height is 1, going down is -1. So if we get its absolute value, it also turns out to be 1. And then the third one is the horizontal asymptote, which is just x is equal to 0, so we get 0. The fourth one is the vertical asymptote, horizontal shift, not asymptote, and the vertical shift. So the horizontal shift and the vertical shift. Then the fifth one is the scale. The scale, we said it's period over 4, so 360 over 4 is equal to 90. So I've done all this to explain what it means when I say the scale. 90 is the scale. This is helping us to decide the spacing. When we start from 0, how far do we go for us to have our first point? How do you guess numbers to put on the table? When you use the scale, it will give you these important points. Okay, from 0, you add the scale. 0 plus 90, you get 90. 90 plus the scale, which is 90, we get 180. 180 plus the scale, which is 90, 270. 270 plus the scale, which is 90, 360. I hope now we understand what the scale means. We want to use it in the next example. It won't be this direct.
Sir,
Hello.
how did we find B on the graph? How did we find B for us to come up with the period?
B is the coefficient of x. Look at where B is sitting. It's the coefficient of x. Have you seen that?
Yes, sir.
So when we say bx, and we're talking of sine bx, so B is quite here, so we just have sine x, meaning B is 1.
Okay, I get it.
Okay. These properties for sine apply also on cosine. So our exercise will be coming with cosine, because today maybe we'll concentrate much on sine. Until you understand, then I'll give an exercise on cos. Okay, so we got the next one, the next example. 2 f of x is equal to 1 plus 2 sine 2x plus 360. Maybe let me use just a small number here. Plus 90. So after by using the degrees, maybe we understand degrees better than radians. So we started the degrees. So we get the properties. The period. Now, if you want to use the scale to sketch this using the table, there's no need of getting the period, getting the amplitude, getting the vertical shift, the horizontal shift. All those are not necessary if you are using the table. Now, let me demonstrate without stating what the period, the amplitude, what this is. So I'll just get the period because I want to get the scale. But I won't mention the amplitude, horizontal shift, vertical shift, and we'll have the sketch coming out. So we'll just get a period so that we can use it to get the scale. Okay, so the period is 360 over B. So we have 360 over B. What is B? B is the coefficient of X, which is 2. So the period is 180. Meaning that the scale period over 4. That is 180 over 4. This is 4 into 180, we get 45. So we get 45. Then we go to the table. The table normally we will be given the interval in which we must sketch this function. If the interval is not given, then you will sketch within the period. In this case, there is no interval given. So we'll sketch starting from 45 all the way up. So we'll just add 45 to know the length 45 plus the period. The period is 180, so plus 180. So we'll get 225. This is where we'll end. That is where sine will have its complete oscillation. So we start, 45 is our first number to be written here. 45 plus 45, we get 90. 90 plus 45, we get 135. 135 plus 45, we get 180. 180 plus 45, we get 225. So we end at 225. Then we start getting the values. What is f of 45? So don't worry, the number that will be coming out will be very normal. 1 plus 2 sine 2 by 45 plus 90. This is 1 plus 2 sine, This is 90 plus 90, we get 180. Sine 180 is 0. So 2 times 0, we get 0. So this will give us 1. So we have 1 here. Next will be f of 90. F of 90 will be 1 plus 2 sine 2 by 90. So I'll be slow, by 90 plus 90. This is 1 plus 2 sine 180 plus 90. That is 270. Sine 270 is -1. So we have 1 plus 2 by -1, which is equal to -1. Next, so this is -1. Then we go to f of 135. That is 1 plus 2 sine 2 by 135 plus 90. This is 1 plus 2 sine, that is 270 plus 90, which is equal to 360. Sine 360 is 0, so we get 1. So we put 1. And then f of 180. So we have 1 plus 2 sine 2 by 180 plus 90. That is 1 plus 2 sine 360 plus 90. Now we understand that coterminal angles, we subtract 360 from n number that is bigger than 360. So here, once you are adding 360, it's the same thing as just getting that 90 and put here. I hope you get a point. The point is, if I have 360 plus 90, the answer here is going to be 450. Now, for you to get 450, you get its coterminal angle. The coterminal angle of 450 will be 450 minus 360, which is equal to 90. So adding 360 is the same thing as not adding it. You just evaluate at this angle here. So here we get 1. Sine 90 is 1. So we have 1 plus 2, which is equal to 3. So we get 3. Now, immediately I get 3, I know that the next number is going to be 1. Because I can't have more than 3 values here. I'll only have 3. If you look at what happened here, we only had 0, -1, and 1. So -1, 0, and 1. There will only be 3 numbers if you use the correct period to give you the correct scale. And then you form the table. You only get 3 numbers. So in this case, I know that even if I calculate this 225, the answer will be 1. Well, because we are not in a hurry, we will check. 225 is giving us 1 plus 2 sine 2 by 225 plus 90. This is 1 plus 2 sine, what is 2 by 225? That is 450. 450 plus 90. This is going to be 1 plus 2 sine 450 plus 90, that is 540. Then we get its equal terminal angle. So we say 540 minus 360. That is 540 minus 360. That's 180. So we have 1 plus 2 sine 180. So we get 1 because sine 180 is 0. So we get, the beauty of the table is that if you understand what goes on in this table, you only calculate 3 numbers, then you are done. No matter how long the table should be, even if they stretch the interval, once I have 3 numbers, they will keep on alternating. I have this one, the next one is this, the next one, the next one, just like that. Now we have found this table. We now want to sketch. So we'll sketch. So we are starting from 45 and then moving to 90. You can see that the spacing is the scale, which is 45. Then we move to 135. Then we move to 180. Then to 225. At 45, it was 1. So we press 1 here. So we got 1 at 45. Don't worry, we are together. So 45 stroke 1, 90 stroke -1, 135 stroke 1, 180 stroke 3, 180 stroke 3. And then 225 stroke 1. Then we sketch. So the sketch is going to be of this form. I don't know what the amplitude is. I don't know what the horizontal shift is. I don't know what the vertical shift is, but I have the sketch. And from the sketch, I can tell what the amplitude is. The amplitude is 2. How do I know? I just subtract 3. I just look at this gap here. This is always the amplitude. This is always the amplitude. If I get it's the absolute length. This means that for you to sketch without any difficulties, you must get back and understand the special angles. Because we are using the special angles here. What have we done? We got the period 180, that is 360 over b, where b is the coefficient of x, which is 180. Then we broke it in 2 pieces. 180 divided by 4, we got 45. Then we have 45, we have 90. How are we getting these numbers? Since we said 45 is a scale, we start at the very scale, 45, and start adding 45 plus 45, we get 90. Plus 45, we get we get 135, and then plus 45 plus 45. So here I've just realized that we have sketched, yes. Because the question was free, there was no interval given. So this graph is correct. But in the normal case, we are supposed to start from not the scale, but from the horizontal shift. So we need the horizontal shift here. So I explain in the next video, what we'll do is we'll have examples with intervals given, because you must always be told where to start from. So we'll do with the intervals given, and then you see how we appreciate the horizontal shift as well, because it must always be our starting point, even if we are not told. Here, we use the scale, but because there was no interval, so the argument is simple. The sketch is correct. It can start from anywhere, unless you are given the interval. Okay, so let me give you a simple task. A very simple task. Yes.
On the issue of periods, it's like I'm still behind on how we are getting 2 instead of 3 itself. Amplitude, I mean.
Amplitude is the coefficient of the function sine, which is this number here. Then you get its absolute value. If we use the graph, we are saying the amplitude is from the central line, this line here. Is the height from the central line going to the turning point, or the height going to the turning point down. If we start from 1, where do we find the turning point? At 3. So you subtract 3 minus 1, we get 2. 2 is the amplitude.
I see.
Yes. So let me give you a very, very simple task. Sketch, which is a simple task. Sketch f of x is equal to cos x from 0 less or equal to x less or equal to 360. So this is 1843. So join at exactly 7 plus 5. 7 at 1855. So that you have 7 minutes plus 5, that is 13. To sketch f of x is equal to cos x. Please use the table. Use the table method, because we haven't done the other method. We're coming to do the other method when we come back. So use this table here. Okay, let's do the sketch. Get it correct and be happy.